What up, everybody? Good morning. Happy Monday to everybody here at from Electrical Code Academy. My name is Paul Abernathy. Thanks for joining me on Coffee Hour in the morning. As you saw, we have a little bit of a schedule change. I sent out the notifications last week to let you know that on Mondays we are changing the time a little later than our normal. But for the rest of the week, it's again 8 o'clock Eastern time. So again, just a little bit of a time change to kind of coordinate with the schedule that I have. So just wanted to give a shout out to that and I'll let you know that we will be having that little change on a Monday. Okay, give you a little bit of extra time to get that coffee going before we get into code. Again, Monday after a long weekend, you're like, oh, okay, I don't want to do this that early, right? So, and it helps my folks out on California, at least for Monday. Thanks for joining me today, folks. Hopefully everybody had a wonderful, blessed weekend and got caught up, rejuvenated, ready for the week, ready to get out there and make some money and boost our career, make advancements, make relationships. Again, I'll remind everybody out there, shameless plug. Anybody out there that's looking to buy wire and cable, I recommend you go to Encore Wire Prismium, okay? Best wire and cable manufacturer in the world. Again, I say that now world because they're available all over the world. So check it out. Okay. Shameless plug there. So at any rate, all right. Anyway, thanks for joining me. As always, I love the shout outs. Let me know where you're from. If you're in our program, what's going on in your life? Are you preparing for an electrical exam? Are you getting ready for it? Just anything you want to chat about. We're open to chat about it. And Adam's figured it out. Well, it's got the coffee kicking in. His brain's going to be working again. So again, thanks for joining me and thanks for always being there, Adam. I appreciate you. So guys, let me know about anything you want to talk about. I'm more than happy to elaborate on it and dive into certain topics. But again, appreciate you all joining me from everywhere throughout all parts. Now, we are streaming on Rumble, Instagram, YouTube, 2 channels on YouTube, our Let's Ask Paul channel, as well as if you're not a member of our Let's Ask Paul channel, go subscribe to that too. That's on our YouTube channel. And of course, our LinkedIn platforms, as well as our Facebooks. So there you go. So let's see here. Good morning. Raining for the next 5 days. That sucks. We're in that new house here, and the rain causes nothing but mud. We can't get the grass to grow. And so I have 3 little dogs, mountain feist, and of course they're into everything, and that includes the mud. So again, Adam, Portland, Oregon, joining us. And again, Paul hollering from Houston. Okay. So let me know where you're from, guys. If you have any questions you want us to talk about, more than happy to discuss them and look at them. But we're going to get into some exam prep questions again, and we're going to dissect them out. We'll use the index very little. Again, I don't want it to become a crutch for anybody, but as I always tell you, you do want to get used to using it. I mean, it's one of those things where you just need to be very familiar with how it works, that type of thing. So we got Mike, good morning from Michigan. You're most welcome. I hope I can share enough that helps you get over that hurdle. Okay. Next month, you're taking your master's. Okay. Good luck on it. Hopefully these episodes help you. These episodes, by the way, will be on all their social channels until they're not. In other words, we move them over to Fast Tracks Tube. So that's again, we purposely delay that so that you can watch it on replay on any of your social channels that you happen to be on. Eventually, they will make their way over to Fast Tracks Tube, and they will be in their separate series header just for the coffee hour stuff. But we are really slow walking that so that it was the thought was we'd move it really quickly, but we're slow moving it because there's so many people that's sending us emails that look at it on our other platforms. So we're like, okay, well, we're going to drag our feet a little bit. That way people can get a chance to watch the various episodes if they're helpful to you, that type of thing. All right, let's get in some code questions for today. And again, as always, give me a shout out. Let me know where you're from. Ask questions interactive, because at the end of the show today, we will be doing some drawings again to get your name in the drawing. And so just so you know, so you hang around, you could win a Fast Tracks Tube subscription, the annual subscription. You can win a grounding and bonding course. You could register to win that. A 2023 enhanced exam prep, you could register to win that. And a mastering the NEC course, you could register to win that. But also you can register to be in the drawing for the estimating software, over $3,000 value that's been donated to us by Steve Griffin over there at Hybrid. And so Best Bid Hybrid. So Steve, thank you for donating that to give away to our members, again, in the drawing. And of course, he's also giving away a course, which is probably, to me, probably to most people more valuable because it's going to teach you how to do estimating and all the little nuances like man hours and how to modify those and changes. So that's, to me, it's probably, if you don't need an estimating software, that's the one to win if you're interested in that. But again, we're giving away courses and we'll be adding additional stuff as we go. Okay. We should know by the end of this week what additional items from the engraved category we'll be adding. So if you're interested in things like our engraved coins or things like that, we should know which ones are going to be approved by the board of directors by the middle of this week. Okay. I left it up to them. It's an easy way for me to say, hey, honey, where do you want to go eat for dinner? And then she doesn't want to make a decision. So now I can say to the board, hey, which ones do you think we should give away? And let them make the decision. Okay. So anyway, thank you all for joining me. Let's go on and get into some exam prep questions real quick. All right. Remember, participation is how you get selected. How about that? Participation is how you get selected at the end of the day. Not everybody's going to make it. But that's how you get selected to spin the wheel of goodness. All right, let's get started. Each multi-wire branch circuit shall be provided with the means that will blank disconnect all ungrounded conductors at the point where the branch circuit originates. Now, this is probably one, if you get this on an exam, folks, this is one of those ones where deductive reasoning, okay? So if you think about how this one is written, then you're thinking, okay, well, how should it be done? Well, how does the code say it? Well, simultaneously disconnecting all ungrounded conductors. That means we flip the switch. They all go off at the same time. Makes sense. We know how a multi-wire branch circuit works. We have to make sure that somebody's not messing with a circuit that may leg A is still hot and leg B may be cut off. So again, there's simultaneous, instantly, or automatically. Don't know about all those. Or of course, none of the above. Now, when I'm looking for this, typically in the NEC, I'm thinking this is a branch circuit. So I'm thinking of branch circuit. And when I think of branch circuits, I'm thinking this is talking about the circuit. So it's going to be up in the very front of branch circuit. But we also know that branch circuit is in the index, right? So we could just get that out of the way and go to the index here. And let's see here. We could go down to branch circuits. If you didn't know, here's B. Right there. And we could go down and look under branch circuits. If you didn't know the answer to this, there's branch circuits right here. All right. If you can see the branch circuits and what we're looking for. And remember, it's talking about disconnecting ungrounded conductors from multi-wire. So we can look down. And by the way, when you see the wording over here, and then you see it's indented to the right, then that's specific to branch circuits. When you see something that's indented even more here, that's specific to, for example, calculations for appliances, that type of thing. So just so you understand how things are when it comes to indentations and things like that, okay? Anyway, so we can look down and see if there's anything remotely in here. You're scanning it out and see if there's anything general purpose, individual, yada, 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 okay? Let's go back up. Branch circuits is pretty big. So we're going down and let's see here. Okay. Multi-wire right here. 210.4. Now you see there's a 393, there's a 700. Y'all should know right away, those have absolutely nothing to do with the general nature of this type of question, right? So we're going to be jumping to 210.4, right? So that's where we're going to go. And let's go back here to the NEC. And we're going to be going to 210.4. And here's our multi-wire branch circuit. Okay, yada, yada. We're looking at there. And of course, so this is the general. And then we're going to see, disconnecting means. All right, so each multi-wire branch circuit shall be provided with the means that will simultaneously disconnect all ungrounded conductors at the point where the branch circuit originates. Okay, that's what it looks like there. So I see some folks in the chat. Paul's jumping in, Adam's jumping in. All right, so we'll go back to the lesson. And obviously, of these choices, simultaneous would be the choice. And here we can see Paul's participation in there. And Adam supported Paul with the code reference. Way to go. That's what I'm talking about. All right, next question. Receptacle outlets shall be installed on or above the kitchen countertops, but not more than blank above the kitchen countertop. Okay, so again, this is one of those ones we're going to try a little trick of memory. Okay, so our memory is look at this question as you see it on the screen, read it, and try to lock in the key things. Okay, we're talking about receptacle outlets, and we're talking on or above the kitchen countertop. So this is about countertops. So this is about spacing. Remember the golden rule when it comes to spacing, where you should start your journey. We've talked about this in previous episodes. And then we're talking about those answers, 12, 16, 18, and 20. All those things should be rattling around in your brain, right? As you start to move into the code book. That way you train yourself so that you're looking at it. So when you're on an exam, you're looking at the question and you're locking in some of the key topics so that we don't forget it. So what are we thinking? I'm not looking at the question. I'm thinking, okay, so we're talking about this receptacle outlets on or above the countertop. And we're talking about how high we can be above it and what complies. And you're thinking, okay, some things to remember when it comes to receptacle outlets and not the device. The device is the device that goes in the receptacle outlet. Okay, I get that a lot from people. Say, ask me on a countertop around the kitchens, for example, they go, do I have to have duplexes? No, you can have simplexes if you want. It would kind of be weird looking, okay? But at the end of the day, it would be okay to do that. Hey, what's up? We have Jeff is in the house. Jeff, are you getting a new name? This is your YouTube channel. Everybody, if you love to do engraving, you're an engravist, you want to check out Lasering by Jeff. Obviously, his channel is going to be R.E. Shep. But again, he does it on TikTok as well. Make sure you check out if you're into lasering. Okay. He loves doing those coins that I just will not venture into because I don't have the patience for a 3-hour coin. But Jeff has the patience, and he will do them. All right. And he has a stalker. If you haven't watched one of his latest TikTok videos, he has a stalker that follows him around Target, that type of thing. So, all right. So, anyway, so when you think of that question, those are all the things that we're looking for, right? Okay. So when it comes to the NEC, we're thinking, what's the golden rule? The golden rule is that when we're talking about receptacles, we're talking about receptacle outlets, and it's sounds like a location thing, anywhere remotely location thing, let it trigger your mind to say, you know what, I'm going to go to 210.52. I'm going to start my journey there because I know that is the holy grail of receptacle outlet placement requirements. Because you know, in commercial applications, there is no place. It's whatever the engineer wants, right? Except for the sign circuits and stuff like that. But for us, when I see a question like that, it's like a kitchen. So I know it's a dwelling. And remember, even if it's a multi-family building, the individual dwelling units are still germane to 210.52. So that's where I start my journey when I'm thinking of that. So I'm thinking, I'm going to start my journey right here. And this is dwelling unit receptacle outlets. I'm starting my journey there, okay? And then I'm going to go down and I'm saying, well, obviously I'm going to be bold scanning to get down to what's germane to the topic. Hold on here. I got something coming up on the screen. Make sure I get that. And I'm sitting there going, okay, well, I know that what's germane is C, countertops. And we're talking about in kitchens, all right? So we're going down here and it's talking about what? On or above. So we got C, 1, it's the wall, 2, that's the island. Now this is the location, 3. Obviously it falls under countertops and work surfaces. So this is a specific, thanks for joining, Jeff. Thanks for stopping by. So we know that it's a location deal. And since we're talking counters and kitchens and it talks about countertops, then we know it's a location deal. So we should automatically cue in that it's 210.52C. And then we end up going down and looking at the location requirement, right? So that's where we're at. So it's not about the wall. It wasn't about the ones required at the island or peninsula. It's specifically about location, right? And the first one, it triggers us. We see a 20, which we know was in our question, by the way. And so it says on or above, but not more than 20 inches above a countertop or work surface. Okay, so 20 inches. So that brings us back to the question, right? We look at the question again. It says receptacle outlets shall be located on or above kitchen countertops, but not more than blank above the kitchen countertop, right? So in our mind, we saw that it was 20 inches. Now, interesting with that is many people probably remember years ago that was 18 inches and it was moved to 20 inches. So the concept is to get up into the bottom of a cabinet, and traditionally that would be, up in whether it's tracks or plug mold, nasty as some people say that is. Some people, believe it or not, just don't like to see the receptacle. I don't get it. It seems like I'm more and more getting it these days. My brothers even called me about it, is that homeowners are like, I don't want to see a receptacle. I'm an electrician. I'm like, dude, I love receptacles. I don't know the problem, but you're getting homeowners like, I want a clean backsplash. And I think it's because they spend so much money in those backsplashes. They're like, I don't want anything. And I'm sitting there thinking, dude, I want them. I want to be able to plug my crap into it. I want them in my cooker, my crock pot, whatever I want. So I don't see the big deal with it, but you do have the ability to go up 20 inches above, and that would allow you to put that plug mold right inside underneath. And they have other types of things now that manufacturers have made that'll go in that top piece up there so that you can plug your receptacle straight up into it. It's not more than 20 inches from the countertop, and it's compliant, and you don't have to have them. I remember one job here when I was out in Texas that I got called out on to do an electrical inspection, and it's only a couple years ago. And it was out in the county, and they didn't have any rules. They didn't have any laws. I didn't have regulations out there, right? And so when the electricians were installing in the city, they followed whatever the city had inspectors. But out in the county, they didn't have inspections, but they did home inspections. But the homeowner called me and wanted me to do an inspection. So I actually went and did the inspection. And the rules in Texas, is like many places, even if the jurisdiction is less, because Texas is a state rule, then what happens is they don't really care what you do as a locality, but you still have to meet the requirements of the state. So the electrician told him, I don't need to put your receptacles. He actually put them up in the cabinets because the homeowner didn't want to see them. And I was like, well, you got to have them. She's like, well, I don't want them. I'm like, you got to have them. And this electrician can't put them up in the cabinet. They have to be down and they have to be within 20 inches. So he had put them all up in the cabinet. So I wrote him up on that. And he was like, well, I'm out in the county. There's no rules out here. And I'm like, yeah, but you have to follow the state. So if something happens and an investigation comes out of it, they're going to come after you and say, I don't care what the homeowner said. I don't care what the locality said or the county said or lack thereof. You got to meet the state. And the state says you follow the NEC. So anyway, long story short, they had to move those receptacles and get them down so that they could be there. So remember, and the whole moral of that is it's not always what the homeowner wants, right? They might say, well, I don't want this or I don't want that. But if code requires it, then you're handcuffed when it comes to electrician. You're like, I'm sorry, but this is what it is, and I'm installing it. So get over it. All right. So we got 20 inches, and here's our reference right there. 210.52C31. Boom, boom. All right. Next. Okay. Next question. Let me move my thing here so I can see. There we go. All right. Next question. When the optional load calculation is used, so this is an example of a question where they're telling you right up front that it's going to be an optional method. And remember, it's always a standard method on exams unless stated otherwise. So in this case, it's letting you know right off the bat. It says when the optional load calculation is used, the heating load in a dwelling that is controlled by 4 thermostats will have a demand of blank percent. Okay. So what do you think? So it's this is one of those ones, let's test our memory, guys. This is what we're here for. Read the question and lock it in, and I'm going to leave the screen. We're talking about optional method. Okay, so you got to know which part of the code, and you know calculations where you go in the code. Article 220, I'll help you that far. So optional method, you know what part it is. The question here is about doing an optional method for a dwelling. Okay, and we're talking about controlled by 4 separate thermostatically controlled heating loads. Okay, so 4 thermostatic controlled heating loads. What is the demand factor when you're doing the heating load calculation for that? Okay. All right. So I like to now you got to lock that in. That's what's going to make you better, is reading a question. People say, I'd like the question to stay on the screen. No, we're not going to do that. I want you to look at the question, and while I'm looking at it, discussing it, you're going to lock it in, because that's going to help you as you maneuver the code so that you don't have to keep going back and forth to questions, that type of thing. It's just going to help you in the long run. That's what we're here for. All right. So from that case, we're going to go to the NEC, and we're doing a load calculation. And some things I'll just tell you. You got to start remembering that part 3 of Article 220 is standard methods. That's the standard. That's what you're going to be asked for on an exam, unless they tell you optional. You don't get into optionals until you get to part 4. In part 4, they'll have to reference that on an exam. So it's not one of those things where you go, I have no idea what that reference for, Adam, unless this is a delayed response. That 230 has nothing to do with this answer. But anyway, so at the end of the day, we have to remember parts of the question. This is a load calculation, and it's based on a load calculation. Still a little off, Adam. Still a little off, because we're doing optional. Okay. All right. So let's go to the NEC and see what we got. See if we can't remember this question. Okay. So here we are at the NEC, and we're obviously going to be in 220 right here. Load calculations. Okay. Now, since it told us this was an optional method, right? Fat fingers. So we go all the way down here. So we know it's optional. So that means since it told us optional, get used to that. So you know you're going to go to the optional calculation, and we'll just get right down here and just start right here at 220.80 and make it simple. So here it says the optional feed on a surface load calculation shall be permitted. Okay. So this is what I get a lot of times from people say, when do I know when I can use in real world? When can I use an optional over standard? Well, you're going to be permitted to use the optional. You can always use the standard. And it probably is going to result in a service that's larger than necessary, because the optional plays on a lot of diversity. So definitely, I would say 99% of the time, or even more, in the field, when it comes to dwellings, for example, you're going to be using the optional method. But don't let that confuse you with an exam. On an exam, okay? Now, also, I'll remind you, like TGA, I'll remind you, let me look at the question real quick. Always remember the questions, because that answer you gave is not an option in the questions. Okay, so it's always important to lock the questions in your head. Okay, that type of thing. Okay, all right, so we're here. Here's a dwelling unit, all right, and we're doing 82, which is, again, basically just a dwelling unit. We're doing this calculation, and you see the general requirements, and then you see the heating and air conditioning loads. And the question is about the heating. Well, we have 65% of the nameplate rating of the electric space heating if less than 4 separately controlled units. And ours was about what? 4 controlled units. So it says 40% of the nameplate rating of electric space heating if 4 or more separately controlled units. Okay? So in our case, our question told us that we have 4 controlled, thermostatically controlled units. And so when we're comparing, and it didn't give us anything about AC, so we're doing what? We're just looking at the heat. And it's just telling us from the heat aspect of it, if it is 4 or more thermostatically controlled units, then it would be 40% is what we're going to use, right? You're most welcome, TJ. I knew what you're looking at. All right, so let's get back to the lesson. And obviously answer here. Now, these two right away, you could throw out, but it just so it doesn't, people don't confuse you, because in the standard method, I'm going to be taking the heat different than this, right? So it can get confusing for people. So that's why we want to break it down. And the key triggers here, one was it's the optional. So you know that it's going to be in part 4. Okay, we know it's the heating load, and we're dealing with the dwelling. Okay, it didn't say multiple dwellings, it just said dwelling. And it is controlled by 4 thermostats. Those are the key elements that we have to break it down, and that's how we got the 40% right there. 220.82C5. Okay? Just break it down, take your time, look at the questions. And there's a reason why I go to the question, right? And I do the question, and then I will give you enough time to read it, try to lock in some of these. And this is what we call, when you're looking at an exam question, you've heard me talk about looking at it and pulling out the trigger words or the target words or the things that mean the most. Maybe they're words you're going to use to search in the index, things like that. It's part of the practice. So that's when I tell you folks to take a question, get your money's worth. All of these questions are in our database, by the way. They're included. Hundreds of them, over 800 plus. Take each question and dissect the crap out of it. So if I was doing this question in my private study session, I would be looking up heating loads in the back. I would be looking up thermostat in the back. I would be looking up demand factor. I'd be just picking this question apart and getting my money's worth. People say, well, Paul, I only got 2 minutes on an exam. Why would I want to do that? Because you're not in the exam. You're trying to learn what's in the index, what's not in the index. You're trying to dissect a question, and it helps you. When you get down to the last 2 weeks before you take a test, then you can start timing yourself. Putting timers on your phone, 2-minute timers. Don't use the timers that are built into test questions. Use a 2-minute timer, egg timer, whatever you want to use, and do it that way so you can do the time each question individually. Like I tell people all the time, don't really worry about the 2-hour timers. Now, some of them we give you that in some of the courses, but be honest with you, I would prefer you dissect it out and put 2-minute timer when you get down to that last 2 weeks rather than be stressed of a 2-hour timer. The reason for that is it forces you to hone in on the question. And so that's what we want to do. And it allows you to see how quickly you answered it. If I have a 2-minute timer and I answer it in 1 minute, I look down and I have a whole minute left. And you realize how that's going to build you time up during an exam. Of course, don't forget our fundamentals. Answer everything you know right away on an exam. Answer it right away. Things that take you more than a minute, check mark it if it's electronic or write the number down on your paper and go on to the next question. Please, by all means, don't fall into that exam trap. Whereas you get so focused on a question and you want to pass this exam so bad that you get tunnel vision and you focus on a question. Next thing you know, tick, 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 and you get struggling at the end, and then you start guessing. There is a way to manage your time on an exam. If you haven't watched my video on that, please watch that video because it will train you to understand the wave sequence of how you should really take an exam. And it also takes the stress off of you while you're in an exam. Okay? All right, let's answer another one. All right. Okay, this question is one of those ones that I look at. Oh, hold on. Make sure people are texting me. So this is a question that really looks that right away. I'm going to look at this and I'll know exactly where I need to be because you should be trained by now. When I read this one, it says A blank is a point on the wiring system at which current is taken to supply utilization equipment. Okay, when I see this kind of question, I immediately know what they're asking me. They're saying, dude, this is defined somewhere. So look at this question really hard because questions you get like this, that it's making a point blank statement that's basically describing something, and you look at the answers and you say, okay, connection point, outlet, opening, supply point, things like that. You know, it might be common sense on this one to think, well, what's that got to do with the connection point when it supplies utilization equipment or opening? What the hell has opening got to do with it? You know, or supply point. That's a terminology that we don't use in the code. And if you're savvy and you've been through our program, for example, you'll be like, these don't. The only one here that logically makes sense, right? And this is one also, I will tell you, that is quite confusing for some people because Val has nailed it, just so we can have the discussion. So Val has nailed it. Good job, Val. Hold on. Let me. All right, so key thing is there is so many people out there that still do not understand the terminology for an outlet. They don't understand what it means. And again, I get slang, and I've been telling y'all I'm working on what's called a slang reference guide, and I'm working on it. It'll come out probably as a blog in the next week or two. That will be nice for you to print off or whatever. That it kind of brings important references. It's a great little thing to have on your phone, but it's just kind of a reference guide, not only terminology but slang. To help get you where you need to be, whether you're in the field. You obviously can't use it for an exam, but we're coming out with that. It's not like a Tom Henry index guide. It's more user-friendly type of a guide for normal terminologies and slangs as well as normal language. But anyway, when you look at this, there's so many people, even educators out there, that tried to get the code changed when it comes to outlet. And literally, an outlet is a very broad term, okay? It is any point on the system, on the wiring system, where I'm taking from that to supply some type of utilization equipment. So I could have a junction box, and I could come off with a whip over to a piece of utilization equipment. Then that junction box is an outlet, where I'm going to be plugging in a receptacle device into a box that's mounted into the wall. The box is part of the wiring system. I'm connecting the outlet to this. So that is a receptacle outlet box, right? And I'm supplying power to what? Cord and plug utilization equipment. So, and utilization equipment is a defined term as well. So a lot of people, I know for slang, we call, look, I got an outlet over there. I got an outlet over there. That's true. But it's not the device. Device is a receptacle, switches, lighting outlets. It's where we're taking power from the point of the system to supply some type of utilization equipment. And the more people get that locked in, I mean, slang is okay. We know what a plug is. We know what people say, an outlet. In the context of what they're saying, we get it. And I'm not one of those guys that are going to harp on that. We've got some people that take it way too damn serious and go, that's not true. It's like sub panel. I know what a sub panel is. You know what a sub panel. We got a lot of people out there go, I've never seen a panel in a sub before. I'm like, whatever, dude. Smoke your dope. Smoke your crack. The reality is, we're in the field. We know what we're talking. We know what we're talking about. Now, when it comes to the point where you need to be very extremely specific, then, or educators, we should make an effort, educators, to say the right terminology. But y'all working in the field and slang, you know what you're talking about. And a good educator can dissect what you're saying and go, I get what you're talking about. I know what you're talking about. It ain't a big deal. Ain't a big deal. All right? I don't know how I got down that rabbit hole, but anyway. So let's go over to the lesson. Actually, let's go to the NEC. All right, so we're at the NEC. And again, this looks, and a couple of you have said it. TJI has said it. This looks to me specifically like it's describing something. So this is most certainly a definition. One of the things I do recommend folks do is get familiar with your definitions. They are extremely important to understand these definitions. And the other thing to remember is some definitions are germane only to certain articles. And so, again, depending on the structure of the definition, you'll see it at the end, what it's germane to, or it's broadly germane to the entire NEC. So it's important how we've done the index now. In the 2023, every definition is moved to Article 100. Okay, so some things, maybe for hazardous locations, a definition is only specific to a certain article or a specific section within an article. It's only germane to that. And so it will call out the article that definition is germane to. And if it doesn't call out a specific article, then it's germane to the NEC, right? All right, so let me go down here and let's see here. Here we go. So we're at O's. There we go. Here's outlet. Let me click on that here and we'll get a definition right there, okay? A point on the wiring system at which current is taken to supply utilization equipment. Now you see this is under the purview of Code Making Panel 1. And of course, this is some enhanced that says a term outlet is frequently misused to refer to receptacles. Okay, so those educators out there who say outlets should be changed, they don't understand what they're talking about, but God bless them. We need everybody's opinion. It says, although receptacle outlets are outlets, not all outlets are receptacles. Okay, other common examples of outlets include appliance outlets, lighting outlets, smoke alarm outlets. Okay, so you put a round box in the ceiling in your bedroom, it's a smoke alarm goes in it, not a smoke detector. It's a smoke alarm in residences. A smoke detector is one that's connected to a monitoring system. It's typically what we see in commercial, but in a resident dwelling unit, those are typically smoke alarms because they do nothing but do an alarming. They don't call anything. That doesn't mean you can't have a residence with an actual smoke alarm / smoke detector system if it goes back to centrally monitored and things like that. But for example, in my house, I have smoke alarms, but I have a ring device that's next to my smoke alarm so that it detects the sound of the smoke alarm, and then it will send off my ring alarm system, that type of thing. It doesn't change the fact that that is just a smoke alarm, okay? Not a smoke detector, okay? But I digress. Again, there's that slang. We all get it, but as an educator, it's important for me to make sure you know the difference. But for you, we know what you're talking about, all right? So anyway, there you go. So let's take us back to the lesson. And it's obviously, we're talking about an outlet right there. And there's our reference, Article 100. Okay, again, you want to be in the drawing today. I need participation. I need people to be active if you want to be drawn. All right, let's go to the next question. All right, the next one, it says, receptacle outlets shall be calculated at not less than blank VA for each single or multiple receptacle on one yoke in a non-dwelling location. So again, this answer helps because there's a lot of people that would answer this question. And remember the question, here we go, guys, we're going to move away from it. So what is it asking? It's asking, what is the VA for a receptacle? Okay, what's the VA for a receptacle? Whether it's a duplex, a simplex, or a triplex, if it's on a single yoke or strap, okay? Single yoke or strap, and it's a non-dwelling application, okay? Non-dwelling application. So we've analyzed it, and we pull back and we go, okay, so we're talking about not dwellings, because we know that receptacles, the general use and general lighting receptacles in a dwelling is covered under the 3 VA per square foot, right? We're talking about other than dwellings or non-dwellings. So there we have a specific area. Now this is one of those when I remember to tell you that we're still talking about it's some VA value. So it's kind of like a calc. It's a value that you'd use in a calc. So you know it's going to be in 220, but you know it's just kind of one of those things where you're like, well, where is it going to be in 220? Well, you know this is talking about, so this is going to be up near the front because you know that anything part 3 and earlier is talking to things like branch circuits and the standard methods and the pieces that you'll put together. So you know it's going to be at the front. It's not something you're going to see down in the optional. It's something you're going to be up in the front so you can narrow the scope down, that type of thing. All right, so that's how I look at something and try to narrow it down on an exam. So I would start my journey at 220 and work my way through there. And I know that it's going to be fairly early in it because, again, we're talking about the components that we need together. And we know that this is a component we need to have when we're doing an overall calculation for a non-dwelling application, just like the lighting, things like that. So that's kind of how my rationale, how my mind thinks when I see a question like this. Now, this is also one that you may know right off the bat. And remember our process. If you're taking an exam and you know this answer right away, what do? You answer it and you move on. Okay, that's what you do. All right. If it takes you more than a minute, you check it, you mark it, or you write the questions number down if you're doing a written test, and you move on to the next one because you're going to come back to this one later. Okay, if you didn't know it. All right. So in our case here, we know we're going to go to 220, and we're looking at what is the VA per receptacle. All right. We're in the 2023 edition of the NEC because it makes a difference. All right. So let's go to the NEC. And we know we're going to be at the very front of 220. So we're going to do bold scan, make it easy for us. So we're right here at the front of 220, right? And that's the scope. We get it. We got a little pictogram here that's changed a little bit for the 2023 edition. And that has nothing to do with it there. That's calculation. That's just some general information. This is fraction. This is what allows you to round up when it's 0.5 or greater. Okay. Okay. And you know what I found out? James likes the fact that over on Fast Track's Tube, you can log in with any name you want. And today he's logging in as Simplex Sims. So there you go. Put that out on the screen. All right. So anyway, as we go down, and we're going down, and we're going, okay, we're at branch circuit calculations. We're in part 2. All right. And so we're thinking, okay, so we're keep going down through here. Other loads. Okay, so these are the individual components. So remember that in the 2023 edition, 220.14 is all occupancies. We're not talking dwellings. This is in general, and we're going down and see which is germane. So we go down real quick, and there's specific appliance loads. This is the one you use, folks, when somebody says, hey, I don't have something that falls nicely in the category when I'm doing a load calc, right? They're like, well, how do I add a specific load to a specific appliance? That type of thing. This is the one you would use. Okay, so if it has a specific dedicated load and you're thinking, how do I incorporate that in my load calculation on my nice and nifty little forms that we have? This is where you would add anything specific. All right, so there's where you get the reference for dryers. That's what sends you to what we always do, 220.54 and 55. Hopefully you've checked my videos out on Fast Tracks 2 for that. There's the one for luminaires, lamp holders, signs, show windows, multi-outlet assemblies, which we have a video for that too over on Fast Tracks 2 if you want to know how to calculate those. And here's our receptacle outlets, okay? And the first thing I'll notice in here is we had a 90, 150, a 180, and 200. Those were our answers, right? So you see here, it says receptacle outlet shall be calculated at not less than 180 VA for each single or for each multiple receptacle on one yoke, okay? Was it simplex, James, simplex, or a duplex, or a triplex? If it's on one strap, it's 180 VA, regardless, okay? All right, so that's that. And so the answer is going to be 180. Now, they probably don't show any pictures, but they kind of do show a picture, but y'all can't really see it. I don't think I can blow it up any better that y'all could see it, maybe right there. So as you can see, there's James's. Simplex is 180. Duplex, 180. Triplex, 180. Double gang box with 2 straps, 180 piece, so that's 360. And the same down here, it says if you have 4, then it's going to be 90 each. 90, 90, 90, 90. That equals 360. Okay? So, makes sense. Let's see. Here we go. That's a little better. All right, let's get us back to the question. All right, so again, single or multiple receptacles. Key here is one yoke. And remember, non-dwelling applications. So it is 180. Let's see here. TGI says he knew the reference, but wanted to give 180. Appreciate it. There you go, 180. Okay, now it would be, so Val asks a question. He says, non-Valley, it is never going to be 90 unless you have the application where you're dealing with, what does it say? I'll take you back up to it right here. It says, oh, let me take you back to, you can see the code. So it's never going to be 90 until you get to where it says right here. It says a single piece of equipment consisting of multiple receptacles comprised of 4 or more receptacles. That's that square ones you get that have the multiples on the faceplate. When that's the case, 4 or more, then they're going to count as 90 each. Other than that, it's 180 per strap. Even if it is one receptacle on one yoke, it's still only going to be 180. Okay? That type of thing. All right. Let's get back to our question, our example. So there we go. And there's our reference, 220.14i. If you're in the 2023 edition of the NEC, that's where it is. Okay. All right, next one, guys. Let me move this real quick. Oops. Okay. All right. So the next one says I have a 240 volt, a 240 120 volt system that has 9,000 watts on line A. Okay, maybe I need to write something down here. 9,000 watts on line A. So I got pen's not working. 9,000 watts on line A and 8,500 watts on line B will have a maximum unbalanced load of what between them? Okay, what do you think? Now look at the question. We're talking amps. So it's 9,000 watts on line A, 8,500 watts on B. So first of all, I'm thinking I have to find out, since it's 240. Let me move this mic over here. Okay, so I'm thinking, okay, well, let's see here. I'm going to take 9,000. Let's see here. And I'm going to write that one. Hold on. And I'm going to take 8,500 divided by, and let's see here. Okay, we're only dealing with neutral loads, right? So I'm going to do 9,000. Y'all do it with me. Don't let me do it all. Right? And then we've got 8,500, right? And again, the key to this is the maximum unbalanced load. So I will break this down for you. But let's look at it and show you what you don't want to do. So let me take the 8,500 real quickly. By let's see, about 120, and show you where people go wrong with this question. I just want to do the math first so I can show you where they go wrong. So let me divide it by 120. Okay, yep. Okay. So 70.83. Okay, all right. So let's look at this. So this is our question. So the question, read this question so that people don't get screwed on an exam. It says the maximum unbalanced current on the neutral. Okay, so when you're looking at a system like this, right, how would you come up with this answer? So the first thing that somebody would do, let's take it to the chat so I can answer this. So the first thing that some people would do is say, okay, wait a minute, I'm going to take the 9,000 watts, I'm going to divide that by the 120 because I'm looking for neutral loads. So that's what they go. They'd say, okay, I'm going to take the 9,000, I'm going to divide it by 120. Yep, and that is 75 amps. And then on the other one, I believe it's 70.53 amps. And you're saying, well, then it's only 5 amps. No. In this type of question, what it's looking for is when you're looking at it, it's not what's going to be seen on the neutral. When you're sizing and doing this at a service, we're trying to see what is the potential maximum unbalanced load. So if all of a sudden, if I'm doing line A, which is 9,000 watts divided by 120, it's 75 amps, and the 8,500 divided by 120 is like 70.13. If nothing is flowing on B, then the maximum unbalanced load would be the value from what? A. And that would be 75 amps, right? Because that's what's being pulled on A. So this is not a question, and you should know this by looking at the answers, right? You're looking at it going, well, none of this makes sense because obviously if I'm looking at 75 amps and 70 for the other is what's going to be traveling on the neutral. That's not what it's asking. It's if nothing is on B, then all of that neutral imbalance will be flowing. There's no cancellation. Then it would be flowing. Okay. So at any given time, based on these two circuits, what's being pulled, the maximum unbalanced load, the maximum that could be pulled in this situation is 75, right? Because that's what the 9,000 watts divided by 120 is. Okay, so it's not looking for what actually is going to be on there. It's like, what happens if I lose one of them and I have the other one? Which one is going to put more neutral current at the situation? What would be the potential for the maximum? That's how you decide. This is what you're doing when you're comparing. Okay, so remember, that's what you're doing when you're doing the services and you're looking at a neutral, because you're not thinking, well, shit, I can size a neutral for 5 amps. That's the difference. No, it's not how you're doing it. We're saying what happens if I'm pulling this amount of load on this phase and this amount of loads on this phase. If I lose this one, then there's no cancellation. Then I'm going to be pulling the maximum on this one. And that's where the 75 amps would be. So it's the 9,000 watts divided by the 120 is 75 amps. That is going to be the answer. Okay. So that could be a tricky one, but you got to remember that there isn't any, and if you did the math, you'll see that there isn't a value on here that matches you trying to subtract line A from line B. That's not an answer here. So that should be the first trigger that that's not what they're asking. Okay. All right. So back to the lesson. And that is just trade knowledge. You just have to get used to reading that question and understanding what exactly are they looking for. And it's like anything. Don't let it throw you on an exam, because all it did was say, look, I'm pulling 75 amps on this line. I'm pulling whatever on this line. At any given time, if I lose this one is still pulling 75 amps. That is going to be the maximum unbalanced load. Now, in the best of all worlds, they're both pulling 9,000 watts and 8,500 watts at the same time, and then the neutral is only going to see the imbalance of the two, okay? It's only going to see whatever's left, okay, because of the cancellation effect. But that's not how the question is being asked, and you want to use the answers to be able to lead you to that type of thing. So that's one. Just be careful. Don't fall down that rabbit hole of thinking, but your answer's not there for what you're looking for, okay? All right, let's go to the next one. All right. You're most welcome. Yeah, that is one that people see that maximum and they think that they're thinking, well, it's the maximum imbalance. That's what you're looking for. No, it is, you have phase A and phase B. If you didn't have anything on B, this is what is on A. That's what you would use, because it's going, that neutral is going to see 100% of that. That's the maximum imbalance. And that's the way you read that question. So hopefully that did help you out a little bit, because you could get a question like that. There's difference between the questions like that in the real world, and the reality is kind of questions that we would ask in a situation where we really look at a service and think, well, what is really going to be seen on that neutral? What are we going to really see? And then like you're thinking, well, you know what? If A, leg A, and all those circuits are they're pulling their current, but all of a sudden B's not, that's a situation where the neutral is going to see that value that's from A. So that's why we can't size it for the imbalance, okay? What do we think it's going to carry? Because we can't guarantee that both legs are going to be pulling current at the same time. That's kind of why we do what we do, okay? All right, so now look at this one. Y'all have had a little time to look at this one. So this one is, it says a vertical clearance, okay? So we're talking about a clearance thing here. And it's like, okay, a vertical clearance in, let's see here. And we're talking about circuits, okay, for a feeder, all right? Now, what's different in this one is this is a 20 kV. So this isn't our normal feeders. This isn't our 1,000 volts or less type of thing. So this is very specific. This is going to be with 20,000 volt feeder that's passing over the roof of a building that is accessible to cars, but not trucks. Okay, so the first thing that you should be thinking in your mind is you're like, okay, I'm an everyday electrician. This is over 1,000 volts. So I'm going to be looking at this table of contents. I'm going to be finding anything, and we're in the 2023 edition, by the way. I'm going to be looking at anything that says, okay, I'm looking for over 1,000 volts. Now, going to the table, this is a great one. Let's see if the table of contents helps us out. So let's go to, let's see here. Let's see here. Let me make sure it's loading. And let's go here real quick, just for craps and giggles on this one. All right. And so this is obviously medium voltage. We're talking clearances. So the first thing I would tell you, again, we'll do a little lesson on index breakdown and see what we can get. So the first thing, if I'm breaking this question down, you're sitting there learning, I'm going to say, okay, I'm going to go and see something about clearance. Okay, so I'm going to look under clearances and see if there's anything under clearance. Or here's clearances. Hard for you to see it, but it's right here where my mouse is. Okay. And buildings, open, overhead, all right? And I'm looking down here and seeing, okay, I don't see anything big. Again, here, let's see here. Okay, I don't see anything that's really germane to what I'm thinking about, because we're dealing with this, that's clearances. So I'm like, not seeing anything for this. Okay, so I would dissect. So next thing I look at and say, okay, let's see here. I'm thinking medium voltage. So I'm just going to jump down and look under medium voltage, see what we go, because my mind's thinking medium voltage. So let's go down real quick. You got your index, so you can see how I would do it. So go down here and see if there's anything, and then we'll go to over 1,000. But first I'm going to look here at medium voltage, see if I can find it. And this is what you should be doing. on your own. You should be breaking these things down, trying to see all locations where you possibly could get the answer. All right, so let's see here. I'm at metal, okay. So here's medium voltage, right? Okay, so I'm thinking down medium voltage. Let's see here. And I'm looking here, okay. Down there. One thing I'm thinking also that this is because of clearances. I'm thinking this is still a feeder application. So I'm thinking, okay, I'm looking to see if there's anything. Okay, so this is 315, but that's medium voltage conductors, and we're really looking for something to do with clearances, right? All right, and let's see here. So I'm going to look there, and let's see. All right, so I'm like, okay, I don't really like what I see there. So then I'm going to go and say, okay, over 1,000 volts, and I think we're pretty close. LMN. Okay, here's O, and I'm going down through O, open wiring. Okay, it's probably open wiring, feeders going over, but we'll look here. Let's see here. So let's see here. I'm looking down. So, let's see here. And trust me, it is much harder to look at it when you're looking at. Okay, so here's outside feeders. Okay, here's over 600. And let's see here. I'm looking. Let's see, it's over 600. And I'm seeing if this is still under the. Okay, so all of this is still underneath the outside feeders, right? And let's see here. I'm just looking down. Underneath these. And I'll show you another way to do this, but I'm just looking down here. Okay, so here's over 1,000 right here, right? And I'm looking right here. So here is branch circuits. Although this said feeder, let's see what else we got under here. It's just kind of a branch circuit. I just like looking through and seeing everything that we've got. Feeders. Okay, feeders, over 1,000 volt feeders. I don't know if you can see this, but this is part 3. That's immediately where we start our journey. Now, I will tell you another tip on this one. Typically, I would go to the table of contents and look for the articles, and I will tell you this is an article for 2023, deals specifically with this application of overhead. We're dealing with clearances for branch, feeders, and services that are over 1,000 volts. But anyway, I will go to 235 part 3. So we're going to go there. And let me get back to us real quick. Here. And as you'll notice that right here that 235 is branch circuits, feeders, and services over 1,000. So they've consolidated in the 2023 all right here. And I see some people on the screen have already done well. TGI is already on it. Okay. So in this scenario, but it told us to go where? Okay. If y'all remember, the index said to go where? To part 3. So I'm just going to go to part 3. And I'll just go to general right here. Starts right here. And this is minimum ratings. We don't need that. Bold scanning comes into play at this point. Overcurrent protection is not what it asks. Diagram of feeder, not what it asks. Not what it asks. See all these ends here too? That lets you know this is a new article. Okay. Now here, none of this has anything to do with clearances. Y'all already have done it. And, I think I went too far the way it's laid out here. Oops. Sorry. It is laid out funky on my thing. It looks so thin. Anyway, keep going. The wiring, so wiring on building. Open wiring, disconnecting means size of the conductor, switch location, disconnecting means, keep going. Inspector and testing it. Okay, good luck with that. Let's see here. Clearances. Whoop, 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 whoop. Okay, so what we're looking at is 22,000 volts or less to ground. It says clearance over roadways, walkways, rails, water, and open land for conductors and live parts of 22 kV or less to ground shall not be less than the value shown in this table. I assume it'll show the table on the screen. It does kind of weak, but it does. All right, so it's passing over a roof. Okay. And let's see here. So when we look at it passing over the roof, hold on for a second, somebody's texting me. All right, so let's see what questions it has. Okay, so this is clearance over that. Bear with me. All right, so that was for more than. So this one, so let's see here. All right, so let me throw this back up on the screen because I did think y'all could see it all. There. Okay, so the question was talking about what? Okay, passing over a roof of a building that is accessible to cars but not to trucks. Okay, so it seems to me like it's the rooftop, and it's a land subject to vehicle, okay, cultivation, grazing, whatever. Then it says roadway, driveways, parking lots, and alleys, and it just says walkways. Okay. And this, so notice that the first one says open land, so that's not it. This says roadways, driveways, parking lots, and alleys, okay? And then this one down here says walkways, okay? So to me, it is passing over the roof, accessible to cars, but not to trucks. This one is pretty broad. I'm going to say, actually, it's more like a walkway above the roof type area, be honest with you. So that's where I would probably fall of my best possible answers. So if I was going back to the lesson, oops, it won't let me. Won't let me. There it goes. Back here. Of all of these possible answers, we know that it's not 18.5. We know nothing was in there for 12.5. So this is an example of plausible answering. Okay. There was nothing that was 15. So the only plausible answer is, again, not trucks, so it couldn't fall under the roadways where it could allow trucks and vehicles, right? So in my scenario, it's a walkway area above it, okay? Because it's not trucks, so again, it's very limiting, but I would say the only possible answer is 13.5. There's no 15 option, there's no 12.5 option, 18.5 is open land. So this is an example of a question where it may not work, it might not be the best thing that you like. You know what I'm saying? It might not be the answer like, well, I want the perfect answer. It's not going to be the perfect answer. Okay. So that's just an example of where you got to work with what it is. Okay. Don't look for the perfect answer, but that is deductive reasoning. We didn't have an option for 15. We didn't have an option for 12.5. The 18.5 was clearly open land. So the only other plausible option was what? 13.5. So that's how you break it down. Remember, you're going to get some crappy questions on an exam. Hell, to be honest with you, you're going to get a couple crappy questions in our database. I don't write the questions. But at the end of the day, you can get the answer by using deductive reasoning, common sense. Y'all are professionals. You do this for a living. And so you put in the hours, you put in the time, and you can do that type of elimination in order to be successful, that type of thing. Okay? All right. Let's see here. All right, let's do another one real quick. I'm a little over, but that's okay. Let's do another one. All right. Now, this should be a fairly easy question for everybody. This is one that you should answer right off the bat, and you should just be able to move on. On a four-wire delta connector system where the midpoint of one phase winding is grounded, only the conductor or bus bar having the higher phase voltage to ground shall be durably and permanently marked by an outer finish that is blank in color or by other effective means. What do you think? Red, white, yellow, orange? Okay, y'all are all familiar with this one, right? I got everybody throwing up answers here. There you go. There we go. There we go. Okay. And just to drop back, Cesar, Okay, driveway wasn't an option on that other one. But again, remember, we're trying to find the best plausible answer and nothing else fit in that scenario. Okay, that type of thing. All right, so there you go. And there you go. Crazy calls about high leg, delta high leg, bastard leg, red leg, hot leg, a high hot leg. There's all kinds of terminology been used around the country. Hey, one of the takeaways from this, though, is that a lot of people think on that delta high leg that you have to use orange. You only have to use orange if you're color coordinating your phases. Then you would use orange. If you, wild legs also use. I've heard bastard leg, that type of thing. I've actually heard in some places they call it the phase that's the only child, that type of thing, or the middle child. Okay, I don't ask me why, but that type of thing. I've heard weird names it called. But remember, stinger leg, we've heard it called that too. Just remember something, that you might run into it where you see it with numbers and labels. You might see where it's got the little peel and stick labels on them and things like that. Does not have to be orange. There's a ICEA method 4, which is all black conductors, not colorized, but all black. That is okay, as long as you distinguish by an effective means that will let people know that is the high leg, that type of thing. Okay. All right, let's do some drawings real quick and do some giveaways. Now, what I will tell you again about these giveaways, guys, it's all about participation. And at the end of the day, there's some of these are for the drawing, okay? And we keep a list of the people for the drawing. You can win more than once. And it's all about participation and ask questions. And today I'm going to do some participation, but I'm also going to ask you a question or two. And really, it could be on any question. And I just want to see who's the first to respond. And I'm going to make them simple today when it comes to questions. But first of all, let's go through for participation. And let's see here. It looks like when it comes to participation, we've got, Val has been participating quite a bit. So Val, you're the first one up on the slate to see what you can win. And again, what you can win is a free year of Fast Tracks Tube. You can win, be in a drawing for a free grounding and bonding course, all 2023, a exam prep course, enhanced, that includes Fast Tracks Tube. That's a drawing. Also the Mastering the NEC 2023, but you also could win the estimating course that's put on by Steve Griffin, which is amazing, $500 value on that alone. And the big one is you can get in the drawing for the free estimating software, which is by far the next generation one, is by far, my opinion, the best estimating software out there. Okay, now disclosure, I have not messed with the next generation one. I have messed with it and used the hybrid one. The next generation is exactly the same. It's just more intuitive and it adds more bells and whistles. So it does a lot more stuff. So it's only better, but it's the same functionality as the old hybrid method. Okay, so again, that means it's just better. And of course, it's more expensive, but you get to being part of the drawing for that. Are you ready? All right, Val, we're going to put you down. And we're going to spin. All right, and I don't know where the audio went on that, to be honest with you. Trying to see real quick where my audio went. I don't know if y'all heard that or not, but that was, hold on here. Hold on for a second, guys. I gotta fix that because I wasn't happy with that. Because I gotta hear the drawing here. All right, so anyway, Val, whether you heard the spin or not, you won. You were in the drawing for the 2023. No music. Oh, I could do the music. I didn't do the music. Sorry. So 2023 grounding me out just for you, Paul. Wait a second. All right, so I got you, Val. You're for the G&B drawing, okay, which we're doing on March 31st. So after that, I'll let you know when to join us, that type of thing. Okay, hold on. All right, so let's see here. So let me clear this. Val, did you hear the spin? Okay, good. It was just me on my end. All right, I had the speaker off. I like to hear it too, you know. All right, so let's go to the wheel here. Let's clear this wheel. All right. Okay, so the next one we're going to do here is, again, participation. It looks like TJI was very involved. So TJI, you're in the drawing already for the best bid, but you can get added to it again. So it increases your chances if you happen to get that one. So let me write you down. Back on the 23rd, you won that. So let's go on and do it again. So let's spin the wheel and I will do this here. All right, TJI, you win an annual subscription to Fast Tracks Tube. If you're already a member, we can upgrade you to give you another year. Okay, where you get 2 years. Turn that music off. All right, so let's see, Fast Tracks Tube. If you're not a subscriber, go get a free account over on the site, and then we will elevate you. Just reach out to us afterwards, and we will elevate you so that you can get the access to the videos, that type of thing. TJI, you would love to have the best big course. You gotta get it. Your name's got to be drawn. So you're in the drawing once already for it, but you know this time you got Fast Tracks Tube if you want that. As what Mike did last week, if you want to gift that to somebody, we can do a question and I can give that to somebody. If you're already a Fast Tracks Tube member and you want to be generous, then you can do it, and I'll do a question and we can give it away. Let's see the next one. All right, so the next one that we're going to be doing a drawing, all right, let me do it. There's a chat right here, is I'm going to ask you a question, and there's a delay. I get it. Some may be quicker than others, but I'm going to ask you a question, and it's the first one that gives me the most accurate answer. Ready? So here's my question. Ready? So here, what do we start to learn first on Fast Track Tube? Okay, so let me answer this question real quick. On Fast Tracks Tube, it's just a video platform. So you can wander through and watch whatever you want. It's not a learning platform. It's not a lesson platform. It's just a video platform. So you can watch the different videos. There's different videos for different topics. You have a search feature at the top. You can search for motors. You could search for exam prep, whatever. So it's really no rhyme or reason. It's not, Fast Tracks Tube is not an educational platform. It teaches you, but it's a video platform. Okay, so it's kind of like Fast Tracks Tube. And it's kind of like YouTube, if you will, that type of thing. Okay, cool. Thank you, Val. Appreciate it. All right, TGI says he already has Fast Tracks Tube, which is great. You're welcome to give it to someone. Okay, so we're going to spin for TJI's free gift to everybody. All right, so I'm going to ask you a question, and it's the first one to answer it. Okay, you ready? All right, ready? What table in the National Electrical Code deals with the FLC for three-phase motors? First one to answer it's going to get the spin. What table in the NEC, give me the exact table, deals with three-phase motors when it comes to finding the FLC, full load current of a motor? And y'all will get to see it on the screen, and I get it's a delay, but whoever pops up with the best answer, it's got to be the accurate answer. The whole thing, okay? And then you'll get the spin. And TGI, I would join in because you could get another bid, right? Okay, still waiting for the right answer. Again, the FLC for three-phase motors. What table gives the FLC for three-phase? Three-phase. All right. All right. All right, y'all, I'm going to let it go a little bit so y'all can see on the screen who gets it first, because there is a delay. So I'm just gonna go down here while y'all are putting it on the screen, and I will go back and y'all all get to see who gets it first and see all the answers that come out. Oh, Oh, I'm sorry. All right, so let's look at the screen and see who we got here. So it looks like 430, 250. It looks like Val is the first one to get it. A little bit wonky on the reference there. I'm not sure what the W is for, but it looks like Val said 430, 250. I don't know what the W is for there. 450. I mean, the most accurate answer would have been, you know how I am when I grade stuff. The most accurate answer would have been table or T 430.250. That's the most accurate answer. So, okay, we're gonna say Val, you get that one. You had a grounding and bonding correct, but you know what? You get to turn that off. We have to now go and let you do the spin the wheel. Val, you may get added onto another drawing for today. So let's go. And Charles, 430.450 is Transformers. So that's not the right article. All right, Val. I don't know if you're a member of Fast Tracks Tube or not, but you get a free annual subscription. If you're not, then all you got to do is go to fasttrackstube.com, register for a free account, and then email us your information, and we will get you elevated in that. All right. Let's do another drawing. And okay, I'm going to ask another question, so be quick on the fingers. Okay, so let me hide this here. All right, quick on the fingers. I love the Val says pass it on to somebody else. Okay, not interested on to Fast Tracks Tube. All right, so we're going to be doing another question. Answer this question, and you will be in the drawing to take over for Val's. All right, you ready? So this question is, what table in the National Electrical Code is used for sizing your short circuit ground fault protection for motors? Remember the structure of how I said to answer a question. Okay, so this is the short circuit ground fault protection for motors. What's the code reference? Where is it? And first one to answer it. First one, doesn't matter who delayed. Everybody's the same level of delay. So again, remember, even if you already won something, you can win something else, and you could be for a drawing for something else, and you could get the Val did it again. Val did it again. All right, sorry, Val, you're the first one. So it must be streaming pretty quick over on Facebook. Okay, but since we said structures, and structure was important, we'll actually enforce it, and we'll go with Crasum, because he said table 430.52. There you go. T or table, whatnot. Sorry, Val. We'll give it to Crasum. Is that the name? Crasum? Is that how you say it? All right, we'll give it. There, he used the perfect structure table. So we'll go over to the contest now, and we'll start this, and we'll do the spin. All right. Crasson, whatever it is, you are entered in to win the bidding software. That's the big one there. So that is the bidding software. You're in that drawing. If you don't want the software, or you're not interested in it, you could resell it to somebody, I guess. But at the end of the day, make you a little money. Okay, eBay that bad boy. But anyway, there you go. You're entered into that. Okay. So the next one that we're going to do, another giveaway, and I'm looking at Paul again, Montoya participation. So Paul, we're going to roll for you again, give you another chance to win, get you in on this. You have already, let's see, you're already in the bidding for the Mastering the NEC course. So, okay, so let's go on and get you in, Paul, and get you a bid here. Crasum is right. There you go, Crasum. Nailed it. All right, there we go. Paul, you already have a Fast Tracks tube, okay? So you can pass it on to somebody, or I'll give you a choice to spin again. Spin again, and you might get one of the other things. So I would think you have a choice to pass it on to somebody, share the love, or say, no, man, I want to get on that drawing. Spin again. It's your choice. Pass it on. All right. So we're going to pass it on. So what we're going to do is we're going to do another question and see who can answer the question for me. And we'll do it that way. Okay. Next question. If I have a 200 amp service, okay, a 200 amp service, and I've got 200 amp service, and I've got its single phase, 3-wire system, 200 amp service. What is the minimum size service entrance conductors? What's the minimum size? 200 amp service, 3-wire, single phase, 122 40 volt. What's the minimum size service conductors for that? Size. Give me a size. First one that answers. All right, Crasum says 3-aught. Charlie says 2-aught. Tino says 1-aught. I got a bunch of them there, so let's let this. All right, remember what we said it was? It is based on the question, okay? And I got Adam's got some values here. Now, one thing to remember, I didn't say the conductor material, so there's something to remember with that. Always consider what, unless stated otherwise. I did say it was single phase. I did say it was 12240. I said it was a 3-wire system. All those type of things. And I want to know what is the minimum size of the service conductors. And y'all know what you would use with that. We'll assume everybody knows. All right, so we'll go over to the code real quick to answer that. Get rid of that. Get rid of that music. That drives me crazy. All right, let's go to the NEC really quick. All right, remember old 310.12? Single family dwelling. It's 122 40 volt single phase, 200 amp. Well, I didn't tell you about any adjustment or correction, so you could have just come right down here to this table. And for 200, it's 2-aught copper. And I didn't say anything about aluminum. And we said always, unless stated otherwise, on a question, you always go with copper, right? For that scenario, okay? So we go back to the chat. And so it is 2-aught, and it looks like who got it out there first? Charlie. Charlie, 2-aught. There you go, Charlie. All right, so let me put you down here, Charlie. You were the first one that jumped on that. All right, so we're going to spin the wheel for you, Charlie. Everybody else is coming on it as well, but you jumped right on it. So let's go on and spin the wheel for you and see what we can get you in on. And remember, guys, by Wednesday, we should be adding some more stuff. We'll be adding some engraved stuff, coupons for other stuff, and all that kind of stuff. So I'm just waiting for the board approval on that. All right, so let's go on and spin it. So this is for Charlie. Charlie's running a 200 amp today. There you go. Cost of copper, I'm sure you're probably doing aluminum, so you'll probably be running 4-aught, I'm sure. All right, Charlie, let's see here. I don't have you, Charlie. I don't have you anywhere on the list except for you did get registered for the grounding and bonding course. If you already have Fast Tracks tube, you can choose to spin it again, or you can choose to pass it and we'll pass it on to somebody else. That type of scenario. Okay, it's up to you what you want to do. I'll let you have that option. And we will be adding some of our coins. I'm pretty sure they're going to approve our coins. Okay, and we have a couple new designs that are coming out. And so we'll introduce those. I got to get okay with that. All right, Charlie. So you get the tube. So all you got to do, Charlie, is go to Fast Tracks tube. register for the free membership and let us know, and we'll get you elevated, that type of thing. And we'll monitor it anyway. Jeff monitors it, so he'll see you in there, provided your name is really Charlie. He'll see you, and he'll elevate you. All right? All right, guys, that's it for today. Hopefully you've joined me, that you've had a good time today. Again, we do this every morning. We're back to normal time tomorrow, 8 a.m., and we'll talk about something I want to talk about tomorrow's episode, so join me. I want to talk about it. Yeah, hopefully you've enjoyed today's episode and got a little something out of it. Oh, we didn't answer the question, did we? Orange. And there's our reference, 110.15. Okay, there you go. Just want to make sure we at least got the reference in there. All right, everybody. Hey, I appreciate you. You have no idea how much I appreciate it. I enjoy coming in. Yes, 8 a.m. Eastern time, Tuesday through Friday, and only on Mondays will we be a little late. Unless that changes, I'll let you know. But I always usually send out an announcement on the social media. You'll see a little thing about, are you going to attend it or not, that type of thing. You don't have to check it that you'll attend it, but that's where we would make you aware of any time changes. But typically it's 8 a.m. because I like to get started before Central time. I'm on Eastern time, so I like to get started before my other job. So anyway, I took off lunch today to do this. So everybody, take care. God bless. Hope you have a great Monday. Don't get hurt. Only got, 4.5 more days of this week until you have the weekend again. So till next time, folks, take care. God bless.